It turns out that we only have two presentations because Anushka already presented yesterday. So it's okay that we started a little late. My paper is called The Taylor Principle and Inflation Targeting Without a Phillips Curve. It's in collaboration with Konstantin Platonov from Loyola University. And let's see how I any idea how I shift this from within the Zoom? Oh, here it is.
Very good.
Uh, so the motivation for the paper is a group of stylized facts that were summarized by Blanchard in 2016. The first is that long-term inflation expectations are the main determinant of inflation. The second is that long-term inflation expectations are anchored, which means that they are not determined by past inflation. The third is that the relationship between unemployment and inflation has weakened. So basically, the Phillips curve has weakened. And the fourth is the empirical failure of divine coincidence, which means that the Fed faces a trade off between stabilizing unemployment and stabilizing inflation. And so, in addition to that, we can see here on this graph that inflation has been persistently below the target for the last decade or so. And this is despite active monetary policy. And so the question that we ask is whether monetary policy can be improved. And so what we do in this paper is we develop a model that is consistent with the stylized facts that I mentioned. Despite the fact that we have flexible prices in the model, it displays inflation persistence. And we use the model to find a refined condition for determinacy, which is often called the Taylor principle. We then estimate the model in order to obtain a baseline observed monetary policy. And once we do, we find that the observed monetary policy is in fact indeterminate despite an active Taylor rule. So that confirms our theoretical findings of the refined condition for determinacy. And then we experiment with alternative monetary policy to see if we can indeed find a better monetary policy for stabilization. I'm just going to give a very kind of high level overview of the model. It's a perpetual youth model where agents survive into the next period with probability. Agents demand real money. And then the combination of these facts, the money and the overlapping generation, creates a possibility for indeterminacy. We have a representative firm and flexible prices, and we have a monetary policy that sets the nominal interest rate based on an active Taylor rule. And so once we build a model, indeed, this combination of overlapping generations and money creates the possibility for indeterminacy despite active monetary policy. And the question is what to do, how to deal with that from a technical perspective. And the method by Farmer and Bianchi and Nicolo is used here. And then we basically what it does is we assume that the expectational error is exogenous. So basically the difference between actual inflation and what inflation today was expected yesterday, that's an exogenous shock. And we require that that shock is zero in expectation and that it's serially uncorrelated. And this assumption gives rise to the possibility of sticky prices instead of the Calvo assumption, which is typically used in New Keynesian models. And what it allows us to do in addition is to analyze shocks to inflation. So basically, we can use the shock to um, see what happens to the economy when you have errors in inflation expectations. In order to analyze or find the Taylor principle in our model, what we do is we kind of simplify it to a log utility in a steady state, and then we can log linearize the model and reduce it to basically one equation in inflation and inflation expectations. And what we have there is the eigenvalue lambda, which the condition for determinacy requires that lambda would be smaller than one. And what we see in this condition here is that psi pi and psi y, which are the coefficient of response of monetary policy to inflation and to output, are exist in the numerator and in the denominator. And so the relationship between them is more complex than in the New Keynesian model. And the condition for determinacy depends on the parameters kappa and mu1 and mu2. So it's much more complex than in the New Keynesian case. And so in this model, the Taylor principle, the traditional Taylor principle, which states that psi pi is larger than one and psi y is larger than zero, is neither necessary nor sufficient for determinacy. And with those insights, we go to estimate the model. So we take the model to the data of the post Volcker era, where the interest rate was positive, and we use the GDP, the GDP deflator, the effective federal funds rate, the hourly wage, hours worked, and M2 for the monetary aggregate. And we find during the estimation that the data indeed prefer indeterminacy. So despite the fact that the model finds an active Taylor rule, which according to the New Keynesian theory should mean that the model is determinate, we find that the data prefer indeterminacy. In addition, we find that the data give money a positive small weight. So those are the main findings. The results of the estimation itself are here on the slide. These are the posterior densities for the parameters of the model compared with the priors. I'm just going to focus on the top three parameters. So the first parameter, sigma, is the weight of money in the utility function. And what we see here is that the weight is non-zero. So it's well identified and above zero. So it's a small positive weight for money in the utility. And psi pi is above one, well identified. So which means that we have an active observed monetary policy according to the New Keynesian definition, and psi y is larger than zero. So we have an active Taylor rule in the observed monetary policy, and these parameters are fairly similar also to New Keynesian-based estimations. And so we feel comfortable with this result. And then we can use that observed model or estimated model to look at the behavior of the economy, the dynamic behavior of the economy in response to shocks. And here we have three different shocks. We have a monetary shock in the left column, we have a productivity shock in the middle column, and an inflation shock in the right column. And then in the rows, we have the variables of the model. So we have output in the top row, inflation in the middle row, and the interest rate in the bottom row. And what we can see is that the model without a Calvo persistence generates a lot of persistence. So that's kind of the first thing to notice is that we have price, basically a nominal rigidity without a Calvo assumption. And in addition to that, we have persistent inflation. And so we can use this model, the observed model, and compare it to alternative monetary policies. The first monetary policy that we're going to compare it is what happens if we reduce psi y to zero. And so in this type of monetary policy, we the monetary authority responds only to inflation. It focuses on inflation. It doesn't respond to output. And so what we see is once we do that, we have much less persistence of the shocks. So we can return to the steady state. We can stabilize the economy in a much quicker fashion than with the observed monetary policy. The uh, second experiment that we try is we leave the response to inflation zero, to output zero, and we increase the response to inflation to two. So basically, we become even more of hawks in the monetary policy, and we do not allow the inflation to rise, or we respond much quicker and much in a much bigger way to inflation changes. And we see that that reduces the persistence even more. So we return to the steady state even faster. And in some cases, there is a cost, even a significant cost to this type of policy in the form of a very strong initial response to the shock. So for example, here with the inflation shock, when we respond to only to inflation, the output initially drops in a much stronger way. So there is a cost to such stabilization policy. And in order to consider all the different possibilities at once, we perform this sensitivity analysis where we look at the variance, the overall variance of the variables of the model as a function of how much response the monetary policy has to output. And so the x-axis is the level of response to output. The y-axis is the variance, the total variance of the variables of the model. And then the lines are three different responses to inflation. We have the observed response to inflation um, in the black line. Then we have a somewhat more, a somewhat stronger response to inflation in the dashed line, and a much stronger response to inflation in the dotted line. And we have two panels. The top one is for the variance of output, and the second one is the variance of inflation. And what we can see is that in the observed monetary policy, we have sensitivity to the response to output. So once we cross 0.11, 0.13, 0.15, we see that the variance starts to rise fairly quickly when the response to inflation is as observed. Once we increase the response to inflation to 1.54 or 1.84, we see that there is much less sensitivity to the response to output. So basically, if we increase the response to inflation, we can afford to also respond to output without adding much variance to the variables. So this, in a way, summarizes the effect of the different monetary policies in the model to different monetary policies. And so in conclusion, what we did is we developed a model that is consistent with the stylized facts that I presented, which are there's no Phillips curve, there's no divine coincidence, there is endogenous nominal rigidity, and persistent inflation as in the data without using adjustment costs, variable capital utilization, or habits. And we use the model to find a refined condition for determinacy, so kind of a new Taylor principle, and which doubts the determinacy of what's called active monetary policy. And when we estimated the model, we found that indeed the observed monetary policy is indeterminate despite being active. So we found in the estimation that it is active according to New Keynesian definitions, but despite that, the model is indeterminate. And then we found alternative monetary policies that provide better stabilization of both output and inflation in response to exogenous shocks. So that is our paper. And I don't think we have a discussant, so maybe let's just open it to questions and general comments.
Well, thank you so much for your presentation. Do you mind just re-reviewing the alternative monetary policies that are better in terms of both output and?
Sure. So basically, what we see in general is that here, when we kind of experiment in a very rough way with monetary policy, we see that when we focus on response to inflation, when the monetary policy is focused on controlling inflation, we get better stabilization. We get better convergence to the steady state. So it takes shorter time when the economy experiences a shock. It takes much less time to get back to normal. And then when we experiment with even a stronger response to inflation, so being even tougher on inflation, we see that it goes back to the steady state even faster. On the other hand, we see that there is a cost to not responding to output because then the initial response is stronger. And so in order to kind of summarize the whole thing, we do a more thorough sensitivity analysis on the response to output in three different cases.
Mm-hmm.
So we have a case of the observed response to inflation, a stronger response to inflation, and even a stronger response to inflation. Those are the different lines on the different graphs. And then on the x-axis, we see the response to output. And what we find is that in the observed monetary policy, when the response to inflation is, let's call it moderate, we get a fairly a sharp increase in the variance of output and inflation when we start to respond also to output in a significant way. So once we cross a certain threshold, let's say 0.13 or 0.15, we get a fairly steep increase in the variance as a result of that.
And with
However,
that,
yeah.
sorry, with that, I'm trying to think of how inflation overshooting and flexible inflation targeting comes into this at all, if possible. I mean, where you let the inflation run high and you focus, I guess, more on the output. I don't know if this is even, if you can, address that with this model, but that's what I was thinking about.
So what we find is basically the opposite to the change that was instituted, right? So what we find is that what our recommendation would be to actually respond in a stricter manner to inflation. And so you could justify, um, reducing interest rate, for example, when you have low inflation or deflation, then um, you can have low interest rate and maybe even for a longer period. But basically, you have this conflict between responding to inflation and responding to output. And when you have a moderate response to inflation and also response to output, then you have less control over the variables of the economy, and then it takes you a longer time to go back to normal when you have a shock, because you have these conflicting efforts going on in the monetary policy. Once you remove the conflict, so when you respond only to inflation, you converge faster, but you sacrifice the short term a little bit. And so we're looking kind of for the golden policy. And here you can see that if you increase your response to inflation, then the response to output, you can also start responding more and more to output without much cost, right? So you basically can do both. If you increase your coefficient of response to inflation, you can afford to also respond to output in a more significant way without generating much variance in inflation and output. So that's basically kind of the bottom line.
Thank you.
Just to clarify a little bit more. So I'm wondering, you said more aggressive response to inflation. So are you suggesting that if inflation goes down, you should cut rates more aggressively, and then if inflation goes up, you should raise rates more aggressively, or is it only if inflation goes up?
Both. It's a symmetric analysis.
Thank you.
Anything else? Or, yeah.
I apologize if you've already covered this because I jumped in a little bit late into the presentation, but I'm wondering how this model interplays when you look at fiscal policy as well, right? Because if you look at the current state of the U.S., right, and they're trying to pass this new bailout bill or whatever they're calling it, and everybody's concerned about inflation. So I think from your model, it's basically saying, if they pass this $1.9 trillion rescue package and inflation does indeed start happening, we could very easily use monetary policy to control inflation without hurting growth. Is that accurate?
So that's our next project. So we started working on the next paper, which is about the interaction between the fiscal policy and the monetary policy, but it's not part of the of this paper. So unfortunately, I don't have I can have opinion, but but it's not
Okay,
based on the model.
Well, then we'll have to wait and see, I guess.
Yeah. Anybody else, or do we have the other presenters here? Check who the. So Anushka is not presenting, and is Jacob here? I don't think so, right? So it seems that we're all out of presenters. Anushka, do you want to present your paper again?
I don't mind presenting it.
Go ahead.
Okay, 1 second.
Let me see if I can. I probably
Thank
need
you,
to
Amir. That's really interesting. Are you? I just looked at your job market paper.
Yes. Anushka, I made you a co-host so you can share your screen.
Okay. It says that the host disabled screen sharing.
Oh, really? So I made you host. Let's try that.
Okay, there we go. Okay, so I'm Anushka. I'm an undergraduate student from Smith College. And I'm going to be discussing my research, which is how does collective bargaining coverage affect a country's Phillips curve, and what implications does this have for monetary policy? So in my presentation, I'm going to go a little bit over the evolution of the Phillips curve. So the original Phillips curve was developed by A.W. Phillips in the 1950s, and he models the relationship between inflation and unemployment, and this was an inverse relationship. And so what this meant for policymakers is that there's a trade-off between the rate of inflation and unemployment. Then the monetarist view was that this trade-off only exists in the short run and that the economy will move to a natural rate of unemployment in the long run. And then the expectations augmented Phillips curve basically says that the inflation expectations are key drivers of the current rate of inflation, and that is the version of the Phillips curve that I use in my research. So most central banks have a goal of price stability and output stability, but there's often conflict between these two goals when it comes to policymaking. And this relationship is modeled or can be seen in the Phillips curve. And then this is just a very simplified example that drove my initial thoughts when developing my research question. But there has been recent evidence of the flattening of the short run Phillips curve. And there are several causes for this, including lower global deflationary pressures, while
We have
anchored
time,
inflation.
Anushka, you can slow down, slow down.
Okay. And so some of the causes include lower global deflationary pressures, while anchored inflation expectations, because central banks have been doing a pretty good job of maintaining price stability. Increased competition due to increased globalization, and also weakened bargaining power. Because weakened bargaining power is the inspiration for my research question, I just want to dive a little bit deeper into how this, like the transmission mechanism for this. So the hypothesis is that as technology in the workplace increases, this reduces workers' leverage to demand higher wages for the next year. And there have been studies done about certain sectors that have historically been highly unionized, such as the industrial sector. And the industrial sector has been more prone to increased automation and machinery. And that has caused several workers in the industrial sector to have to make a switch into other less unionized sectors, such as the servicing sector. So what are the implications of this for the Phillips curve relationship? Well, one of them is that there is a reduced trade-off between inflation and unemployment rate, if not a diminished trade-off. And so then this begs the more broad question of, does the Phillips curve relationship still hold? So I use OECD data from 30 countries on actual inflation, forecasted inflation for the next year, the short run unemployment rate, and collective bargaining coverage, which is taken as a percentage of employees with the right to bargain. I calculate the natural rate of unemployment by taking the average unemployment rate for each country over the time period in question, which is 1999 to 2017. I use an expectations augmented Phillips curve model, which is inspired by Ball and Mazumder's expectations augmented Phillips curve from their 2019 paper. And I run a time and entity fixed effects regression where I have actual inflation, expected inflation. This is the unemployment gap, which is the short run or the current unemployment rate at time t minus the natural rate of unemployment. And then this is the collective bargaining coverage figure that I also got from the OECD data. And then this is just a graphic showing the average collective bargaining coverage by country, just to get an idea of the kinds of collective bargaining coverage levels that I have in my sample. So while there were some countries that had relatively stable collective bargaining coverage rates for the time period, such as Austria and Belgium, there was also a handful of countries that had significant volatility in the collective bargaining coverage rates. And for example, Greece, which had significant volatility, especially surrounding the time period of the onset of the financial crisis and as well as the austerity measures that were implemented later on. So for my annual data, I run 4 regressions. The initial regression is a baseline regression, so I don't include collective bargaining coverage. And expected inflation is a significant driver of actual inflation, according to my model. And the unemployment gap, though it is expected to have a negative effect on actual inflation, it is not statistically significant. In my second regression, I add collective bargaining coverage as a regressor, and it is highly statistically significant. In fact, my model predicts that a 10% increase in collective bargaining coverage will result in a 0.04% increase in actual inflation. And I found it interesting that the unemployment gap did not have a statistically significant effect, according to my model. And I tried interacting the unemployment gap with the collective bargaining coverage variable, just because, intuitively, I thought that there would be an inverse relationship between the two. However, the interaction term did not have any impact on the statistical significance of the unemployment gap. And the interaction term itself was pretty negligible. A potential explanation for the statistical insignificance of the unemployment gap is that my annual figures were dismissing some variability. And because the trade-off between inflation and unemployment is theoretically only supposed to exist in the short run, perhaps the year or the annual figures are not referring to the short run. So I run the same set of regressions for quarterly data, except for the collective bargaining coverage data, which is still annual. As you can see from the table, expected inflation is still highly significant, as is collective bargaining coverage, which actually increases in significance from the 1% significance level to the 0.01% significance level. And the statistical significance of the unemployment gap is unchanged. So my key findings are that my model predicts that the unemployment gap is not a significant driver of actual inflation for 1999 to 2017 and for the countries in my sample. I also find that expected inflation is a significant driver of actual inflation, and that collective bargaining coverage is expected to be associated with an increase in actual inflation. So the implications for monetary policy are that actual inflation is less responsive to unemployment than it is to expected inflation and collective bargaining coverage. This means that, according to my research, there is a weakened trade-off between unemployment and inflation. and therefore central banks have more room to tackle price stability without compromising employment stability. So Achino finds that central banks can implement monetary policy that is more aggressive towards inflation when the flattening of the Phillips curve is due to structural economic change. I find that higher collective bargaining coverage is associated with higher inflation. And so based off of my research, existing literature, especially Achino's work, I find that central banks in countries with higher collective bargaining coverage can place a higher weighting on inflation when making monetary policy decisions. The other angle that I explore in my paper is policymakers' welfare loss function. And so central banks and policymakers try to minimize their loss function based off of the inflation gap and the output gap. And so based off of my research and existing literature, I find that optimal monetary policy will place a higher relative weight on the inflation gap. And then to tie it all together, because I find a statistically insignificant causal relationship between unemployment and inflation in my sample, my conclusion is that central banks can further minimize their welfare loss functions by placing a heavier weighting on targeting changes in inflation than on unemployment when considering monetary policy decisions, and that collective bargaining coverage is a significant positive driver of actual inflation. That's all.
Any questions for Anushka? Very
Sure.
nicely
So,
done.
yeah, thank you so much. Quick question about your paper. In terms of inflation expectations and like central banks' ability to communicate, their policy decisions, do you have any kind of like analysis of how it impacts inflation expectations and not just inflation outcomes?
Yeah, and so that is one of the central bank's transparency and independence is one of the reasons for lower overall inflation expectations, just because central banks have been pretty transparent. And so there is a certain level of trust in the existing literature that the public does place on policy announcements that that central banks do release, and then that goes into their inflation expectations for the following year. So that I haven't done any analysis specifically on that, but that was I did include that in my literature review.
Okay, thank you so much. Great paper.
Thank you.
Anybody else?
I just want to comment that your papers complemented each other. I thought that was interesting, and I'm sorry if I missed it, but which countries have the higher CB, the collective bargaining? Did you?
Yeah.
Rank that? I'm sorry.
I can
had a graph with that.
I can share my screen again, and then go back.
Yeah, and what are the trends over time?
Yeah. 1 second. So this is the graphic that I had, and this was the average collective bargaining coverage. And so I find that some of the Western European countries, especially like Austria and Belgium and France and Sweden, had exceptionally high collective bargaining coverage rates. And then Greece initially had, I believe it was around 80% before dropping to, the range went from 20 to 30% after the financial crisis and up until 2016. And I believe it started to climb around 2017.
Seems almost bimodal. It's like you either do or you don't. I mean, the ones that are low are really low, and then the ones that are really high. Thank you. Yeah.
So if there are no questions, it looks like we have one presenter short, so we can finish the session a little earlier. Kai, you're the host now, so you'll have to close the session. So thank you for everybody coming in and for your attention and comments. And I'll see you in the next sessions.
Thank you so much. Actually, Amir, I wanted,
Yeah.
or Dr. Gorin, I wanted to just kind of ask you if you had any opinions on Olivier Blanchard's paper on semi-automatic fiscal stabilizers, and kind of like how that ties into your paper. Because I remember looking at that earlier, and then kind of thinking about like the speed of policy response. So I just wanted to hear if you had any opinions on that.
About the last one with the fiscal policy and monetary policy interaction, the last paper.
Yep.
Yeah, it sounds to me like almost justification, kind of countering the fiscal theory of the price level literature, and giving permission to use the combination of loose fiscal and loose monetary policy together, and that will have no, or is expected to have no negative consequence. Am I correct that that's kind of the bottom line of the paper?
Yep. Yeah, exactly.
Yeah. So we're in the process of investigating that and trying to identify what is the price, what is the cost of doing that, and where does it, at what point does it break? So that's our next paper.
Exciting. Thank you so much.
Thank you.
Thank you.
Thanks, everyone.
Thank you. See you later. Bye-bye.